to wiesz, jest zaplanowane działanie, zrobić na początek tak, że byleby świetny dzień było spoko, na pewno nie będzie ale to wyjechali halowe i kurczę, decydent wszystkie ściany i foto. Nie lubię.
Koniec bloku.
Im powiedział,
Właśnie zaraz przed wyjazdem. Mocny. Potem tydzień luzu, takiego wiesz, takie roztrenowanie.
No dobra.
Ale stwierdził, że skoro wyjeżdżam, to mi zrobi 2 dojebane tygodnie. I zrobię sobie tygodnie, tak wiesz, na plaży. Także spoko. Lecimy? Krzyczysz do nich sam, czy mam cię? Przepraszam, będziemy wracać. We are starting next presentation, so if you can take a seat, that'd be awesome.
Jest w prawo. Nie wiem, czy już... Może ci zapowiem? Nie, poczekaj, jeszcze Andrzej nie chodzi. Hi everyone. So today we're going to talk about Node.js in depth. But first we're gonna start with the basics to be on the same page. Node.js, is it single or multi-threaded? Who thinks it's single-threaded? Please raise your hand. Okay, there are some hands. And who of you think it's multi-threaded? It's strange because it's almost the same hands, okay? Let's find it out. So here we have a short code snippet. It starts with a console log at the beginning of the file, and it ends with a console log. We have a function declaration, and all it does, it just prints the start and the end, the beginning and the end, of course, and it iterates 1 billion times. On my CPU, it takes around 1 second, let's say. Then we have a set timeout, which calls this function with index 0. Let's run the code, see if it works. Okay, here we have the output. Nothing surprising, probably, to most of you. So we had the console logs we had at the beginning, and then we had the result of the long iteration with index 0. Let's uncomment the second timeout. And now, what would be the sequence of the result? We know that the long iteration takes around 1 second to be executed. And here we have a console log, which takes for sure less than 1 second. But does it make any difference? Let's see. Yeah, so we see that the second timeout was printed secondly.
single thread.
Maybe. Then we had a new promise. Let's uncomment it. And we all probably assume a promise with something asynchronous, right? Okay, let's find it out. Let's run again. Well, it might be surprising for some of you, for some of you may not, but we see that the callback of the new promise constructor was executed even before the last console log, before the set timeouts. let's move forward to the last function call, and this is just a simple function call, so yeah, shouldn't be nothing surprising. We have it in the end, and before the end of file console log. Okay, let's go back to the presentation and investigate how it works internally. So here we have the same snippet of code. We have the output, which is basically the terminal output, and we have the call stack. And the call stack is a place where we push the code to execute it. So let's start with the first line. So we have a console log beginning of file. We push it to the call stack, we execute it, and we get the output in the terminal. Then we have the function declaration, but of course the first thing it's being declared at the beginning. Then we have the set timeout. So we push it to the call stack. But what is the set timeout? Like if you try to find the set timeout in the JavaScript specification, you won't find it. Like it's not a part of JavaScript. In Node.js, set timeout is a part of Node.js API. So what we do, we call it with this, with passing this callback as a reference, and it just gets registered somewhere in the Node.js. Similarly with the second call, with the second set timeout. We push it to the call stack, execute, it gets registered, and we clear the call stack. Moving forward, we have new promise. And what is new promise? A new promise, it is a part of JavaScript specification, but it was introduced to make a package. It's like a proxy pattern for an asynchronous operation. So all what it does, it just maintains the state of the asynchronous operation underneath. If it's rejected, fulfilled, or pending. If you dive into the implementation of the new promise constructor, you will see that every callback is being passed inside. It's just going to be executed right away. So we step into the new callback. We have this long iteration with index 1. We step into, there's a console log with start. We print it to the output. Then we had a for loop with 1 billion times iteration. We iterate. When it ends, then we go to the next line, to the console log with end. It gets printed out, and we step out of those functions, clearing the call stack. Lastly, we have just a simple function call with index 2. We push it to the call stack. We print the console log start. We iterate 1 billion times again, and we print the end. At the end, we have just the end of file console log. We print it, and that's all. And what happens now? We don't have more items. This is like all. And now Node.js now normally would exit the process with, for example, status code 0. But Node maintains the references for all the asynchronous operations being called. So Node knows that the whole initial file has been executed. Call stack is empty, but there are some references in Node.js API. So in this particular moment, Node.js spawns a mechanism called event loop and the event queue. And what's event loop? So you can think of event loop as on high abstraction level as a simple white loop, as a simple queue. So what the loop does, it just waits for another event on the queue, and when it arrives, it gets processed. In our example, we've called to set timeouts without the second argument, so it's basically like the delay is 0. So the callbacks are being processed right away, and they go to the event queue. And in the first iteration of event loop, we pick the first callback, push it to the call stack, and of course step into going to the long iteration 0. We print the start, then we again iterate 1 billion times. So the call stack is busy right now, right? We cannot like pick the other callback because there is no other call stack instance. So we cannot like process things here parallelly, right? When the iteration is done, we print the end and we step out of this functions clearing call stack. There's one more callback in the event queue, so we pick it up, push it to the call stack, step into, print the second timeout, and clear the call stack. And now the situation is clear. Like the whole initial file was executed, call stack is empty. There are no references. There are no references for asynchronous operations in the Node.js API, and also the event queue is empty. So the Node.js can clearly decide to like exit. And by analyzing this, we can clearly say that this like whole mechanism called event loop is single-threaded because all of the operations are being processed synchronously. But what about other parts of Node.js? Let me show you another demo. So here we're gonna use a crypto module, which is one of the native core modules of Node.js, and we're gonna import pbkdf2. Like it doesn't matter. It is a function that consumes CPU a lot. It basically creates some kind of a key, password-based key derivation function, whatever. At the beginning of this file, we save the start date, and then in every callback, so when this asynchronous operation is basically done, we print that the queue was created with the time difference in milliseconds. And we call this function once. Okay, let's run the code, see if it still works. Yeah, so we see that the one key was created in about 600 milliseconds. Let's run it once again. Yeah, we see that the time is pretty similar. What if we uncomment a few more function invocations? Let's say four of them. Yeah, so it might be pretty surprising for some of you maybe not. But all of the 4 invocations finish after the same time. So we can clearly say that there is some parallel execution, right? What if we uncomment one more and run again? Well, yeah, and it's again, it might be surprising because the 4 of them finish after the same time, 600 milliseconds, and then the 5th took twice more. And why is that? Well,
you have only 4 cores.
That's not true. But you are going in the right way. Let's see the documentation of this method. And what the documentation says. This API loses libuv thread pool. So we have a thread pool here, which can have surprising and negative performance implications, mostly negative, of course, for some applications. And see the UV thread pool size documentation for more information. For me, this one looks like an environment variable, you know, so maybe let's pick it up and change it a bit. Maybe 5, because we have 5 function invocations. And run the code again. Yeah, it might be still interesting and surprising, and not because of 4 cores. So now we see that all of the 5 function invocations finished in around 800 milliseconds. So we have parallel execution for all of them, but overall the time for each increased by 200 milliseconds. Right, so we have thread pool, but why do we need a thread pool inside Node? because everyone says always that we have a single thread, everything is synchronous, do not block the event loop, right? Okay, so the thread pool was introduced to Node.js by the Node.js engineers to solve few main problems. And one of them was that Node.js communicates with the operating system, right? And the operating system interface, some of the functions are non-blocking. For example, TCP, UDP sockets, and mostly the I/O part. But there are also some blocking parts, like file system operation and DNS functions. So for example, if you try to read or write a file on operating system interface or resolve a domain, it is a blocking operation. This is a high-level architecture diagram of Node.js. In the top left corner, the application stands for basically the code you write. This is like the code we write, application user code. It gets interpreted by the V8 engine using the Node.js bindings, the Node.js API. So for example, the set time mode which we used in the first demo. And there's a big library. This is like the fundamental of Node.js, which is called libuv. And it's been also created by the Node.js engineers, but abstracted to a separate library. And here we see that also the event queue and the event loop is provided by the libuv. And the libuv decides if we are using the blocking operation, then it goes to the task queue and it's being processed via the thread pool. And if it's a non-blocking operation, then it gets directly scheduled to the operating system via the epool or KQ. But the libuv, it's not only the library for concurrency or power execution. This is like the main interface used by Node. This is a multi-platform support library. So for example, the Node.js engineers don't have to care about if it's being run on Linux, Mac, or Windows. They are just using the abstract interface provided by the libuv. And the main features of libuv are, of course, all the asynchronous parts, like TCP, UDP, DNS, and the file systems, but also child processes, thread pool, threading, clock. So it means that all the set timeouts and the set intervals you use are being processed on the operating system level. And also user-specified code, which stands for the native code if you write a native C++ module. Okay. But why should we care about these things? You may think like, why should I care, right? So the reason is simple. If you try to write something blocking or CPU intensive, like normally, it would basically block the event loop. So this is what basically Bartus says about the problem they had, right? Yeah. So if you block the main thread, the event loop, your application will be able to accept the TCP connections from the incoming requests because there's a thread pool which will handle that. But your application won't be able to process those requests because to process the request, you have to have the event loop spinning, right? And you can, for example, block this with like I used the for loop with 1 billion iterations, but you can also block it with some I don't know, like algorithm, CPU intensive algorithm. Okay, but what if we really need to write something blocking or which consumes or requires a lot of CPU time? So in Node.js, to do it the proper way, we have few solutions. We can use a Node.js cluster, so basically use many instances but by the cluster module. We can spawn a child process. We can, of course, use the worker thread, which is like the newest and the recommended way in most scenarios. And we can, of course, always write a native Node.js module if you know and like the low-level languages. Which one to choose? it always depends, right? There are pros and cons, but this is a topic for my next presentation. Yeah, it's pretty big, trust me. In the end, I would like to leave you and make you remember 2 thoughts. Do not block the event loop, as Bartosz said, and treat it as a task scheduler. Thank you. I don't have the Q&A slide, so if you have any questions, feel free. Yeah?
I mean, you showed the task queue, but that was actually the macro task queue. But you like omitted a bit about the micro task queue.
There are few task queues, and like the implementation, from the implementation perspective, there's no queue at all. There are file descriptors at the very low level. The queue pattern is just to simplify things, how it's implemented. Some comments or questions? More?
A question, how we can check if actually our Node.js application use all the threads that we have, if we can check that.
How to check if Node.js uses all the threads?
Yes. Like all the CPU calls. Sorry.
So for sure you can use the K6.
I still wouldn't know, I would know just performance, yeah. It's not
yeah,
presenting call log.
Sure. So it's a bit hard to measure because you can simply measure how much time it takes for one spin of event loop, and to make it right, it should be somewhere not more maybe than tens of milliseconds. But to see if the thread pool is consumed, well, you can investigate it via performance tests, of course, but the thread pool was created to basically perform all the I/O stuff asynchronously. So you don't really need more than 4 threads to process the I/O. Like this is like the constant value I showed that you can change it, but normal cases like you shouldn't, and you shouldn't also use the thread pool provided by the LibV because it was created to cover all the operating system things which are not blocking by default. So if you write the code and you really need to block it, like you really have some code which blocks, then you shouldn't offload it to this thread pool provided by the UVP.
I see. Okay, thank you.
Okay, Q. Thank you very much.
Yes.
Sorry, yeah, one more question.
A quick one. In your presentation, when you increase the pool size,
Yeah.
thread pool size, do you know why the time of execution has increased by about 30% from 600 milliseconds to 800 milliseconds? Is
Yeah.
it related to the negative implications comment?
This is for what? Sorry.
Negative implications of the comment.
Yeah. In the
Documentation.
library, DB, blah blah blah, it was mentioned that using this, clicking this option.
Yeah. So the reason for that is exactly because I have only 4 cores. Okay, thank you very much. Now we're gonna have 3 to 5 minutes break.
That's not entirely true. The pizza showed up, so we'll take 15 minutes for everyone to grab some pizza, and we'll be back at 15 past for our third presentation.
Bardzo ładnie, Pani kolego. Zdecydowałeś. No, ale bardzo dobrze. Może się posłużyć do siebie, za to dziękuję, za to.
Cieszę się, kurwa,
Trochę tak. No tak.
Kiedyś pisałem tak, dodawałem
Tak. Że to trochę było jak rozmowa rekrutacyjna. W zasadzie, a ten setback, on kiedy ci się odpali? No dokładnie.
To są moje pytania na rozmowę.
Ale powiem wam, że fajnie, że jedna prezentacja pokazuje się
To może wejdziemy.
To nie coding zrobią jakieś filmiki.
Dokładnie.
ale powiem na początku, że takie Andrzej wspomniał,
Wiecie, jak zobaczysz, że używacie będzie sobie więcej niż 100% znaczy, że działa.
A nie, to tego nie
wcześniejszy coś
Tak, można sobie popatrzeć, właśnie jest... No zwłaszcza jak się Nodejs może ci pokazać takie osobne thready, nie? No ale to nie, jak masz jeszcze VS Code i masę innych elektronowych notek, to też pokazuje jako będzie nic 20. Tylko będzie 7. Nie, na pewno nie ma 4.
Czyli na pewno masz 4, jak 4.
Mam 4. Tak, a co?
Ty masz jakiego?
To jest Starmark. Ale Starmark to jest z 16, 17. Ja miałem, nie, to jest z 15, to jeszcze nie był taki. Nie miał takiego dużego, miałem z 15. I on miał 8. Ale to 8 ale nie fizyczny. No ale to... No i to może mieć znaczenie. Ale kiedyś czytałem taki, znaczy, wyjątkowo no, nazwał The Only Unbreakable Law in Computer Science. I gość opowiadał o tym, no nie po to, ale jest prawo współbieżności, że czas, możemy skrócić czas egzekucji, dodając wątki, ale do pewnego poziomu, ponieważ jest czas na bootstrap tego chora, pewną pracę, której nie da się zrealizować. Myślę, że to
Połączenia, ale one tutaj nie są takie. Znaczy, bo jak masz 4 fizyczne kory,
to jest tak,
nie masz
wszystkie odpalić sobie tyle procesów, ile masz OSCPU. I reagować taki dualnie. Nie jesteś w stanie, że reaguje często odpala swoje testy, to zajmuje tego pola. W sensie, jak spróbuję tyle do roboczego procesu, mamy się często, tak. Więc domyślnie się zrobi jednak mniej. Właśnie po to, żeby ci nie, żebyś mógł jeszcze coś innego odpalić. Przy watch mode to w ogóle spada do połowy.
A, bo tego nie zapamiętałem.
To nie zrozumiałem, że... To jest prostsze.
Smoke testy od samego początku.
Tak, tak. Nie, definicja testu jest jedna, to czym jest test, zależy od tego, ile tekstów jest wykonywane. Czyli smoke test dla jednego użytkownika przez 10 sekund. A słucham? Znaczy, nie ma czegoś takiego, jest albo smoke test, albo performance test. Możesz wykorzystać definicję testu, żeby uruchomić to jako smoke test, albo dla dużej ilości użytkowników load test, soft test, spike test. Jak na przykład robisz sobie z 0 do 1000 przez 5 sekund, to jest spike test. No, to jest spike test.
Test. Hello everyone. We will be starting our first presentation. Please join us.
Hello. Okay, so I want to start with a small announcement. I was inspired by what Andrzej said at the beginning of today's meetup. So everyone can speak, and this is my first talk, and Andrzej helped me a lot with the preparation for this presentation. He is a huge help, and I can encourage everyone to also do it. We should all share our experiences. We can Google anything, but we can share experiences and what works for us, and that's so cool. That's why we meet here. I'll start with the first slide. So yeah, today I want to tell you a little bit about Material UI and Storybook. And this will be the first front-end presentation of today's meeting. I will focus on the front-end technologies. Yep. Okay, back to presentation. I'll be telling you a little bit how my team is using Material UI and Storybook and how to use it easily and I'd say effortless. And also I will emphasize on the huge advantage of using Material UI Components Library in accessibility, which we tend to not care about, and that's not super good. I mean, internet is and should be the most democratic medium ever. There were fights over JavaScript. Every big corporation wanted to own the internet language, and they didn't make it. JavaScript is still free of charge, and anyone can use it, and anyone can access the web and see its context. So it should be everyone who can access it. So people with especially visual disabilities also, and it would be great if we would start caring about it a little bit more. That's one thing from the bottom of my heart. But the legislation actually follows what's in my heart, and it will be soon enforced by law. If you're not familiar with it, you can check it out. It's European Accessibility Act. It will be required for every web page accessible in Europe to be accessible. Otherwise, it will not be indexed. So that's a huge thing. But that's not today's topic. Today's topic will be material design, UI, and storybook later on. So first, what is material design? It is design system created by Google to set some standards for UI that is shared across all platforms in a way that so every user can know how to use your application. If it is consistent, then it is easy to use for our users. And they did really great job in designing it. They did evolve a lot after having user tests, so that's really nice, very solid ground, I would say. And now, material design is a design system with all more abstract rules, and there we have material components, which are small blocks that serve various purposes that we can use. And lastly, we have material UI, which is React implementation of material design of those components, because I also only care about React. Okay, Storybook. Storybook is a tool that helps you, it displays your components in isolation to whatever. I mean, we use it internally. I will tell a little bit more about my team's specific use case, but it's a very nice tool. I will show in the latter part of the presentation how it works. Yeah, the use cases that we apply this tool for is it's basically our living documentation of the components that we have. So it's used internally for developers. Whenever we have a new developer, or we can forget also that someone else built some component already. So whenever we have to build anything, we don't have to go through all the application. We just go to this components library. If the component's there, it's there, then we can reuse it easily. Just copy paste code for the component and reuse it. And if it's not there, we build it, we put it there. So we make sure to reuse code to not repeat ourselves. That's really nice. Next thing is for our business analytics. So whenever he is talking to the customer, and customer has an idea for fancy new feature, he can look through our components and see if the components for this feature are already there. And if so, then he knows that this will be cheaper. It helps him to have the general overview of the price of things that we will be doing. So that's also super useful. And because of this, he doesn't have to ask us all the time. So clear communication. And for QAs, so they can easily test components in isolation even before we finish with the feature. So you can put components in your code. You can have it in your production code base before it's used, and you can expose Storybook to QAs, so they can give you feedback everywhere, which is also nice, less painful while delivering. Yeah, so that is about Storybook. And now let's go to the meaty part of what I'm going to say today, which is styling options in Material UI. There are several, and I did evolve in how I'm using it. I think now it's much more optimal than it was initially, so I'll share my findings with you. This is, of course, covers all in the materialized documentation. I didn't read everything initially.
That's fun.
Yeah, I know, we all do that, so don't yeah. Okay, styling options. We have 4 basic options of styling material UI components. And just to be clear here, with material UI components library, you get the library that's a set of standalone components, and they're perfectly usable without any of your input. And you just copy paste, it works. But everyone wants to customize it a bit because the out-of-the-box set is not ugly, but it is not nice either. It needs some gentle touch, I'd say. And also you don't want to look exactly like every other application. You want to be similar, to be easy to use, but you want to be special. Cool. And I'm sober.
Okay, that's cool.
Okay, yeah. So for ways, one of customization reusable components, global CSS override and global theme variation. Let's see what it is in detail. So one of customization is when you have a component and you have some very specific use case and you have to adjust the component just for this once. That is perfectly good moment to use this one of customization. And you have, can you see my mouse? You can. Okay. So you have this super cool SX object that came in the latest 5th version of Material UI. It is really very convenient. Basically, you can provide all the styles in emotion or styled components style here. You can even style subclasses, so subcomponents of the component. What you can see on the pictures here, the first one, the blue one, is Sote. It's Material UI component out of the box. The second one is just with some color, and then to style the dot here, for this to be square, we have to style the nested component of this, and you can do it super easily using the format that is known for everybody. So easy peasy. Next thing, you can create reusable components. So, and that's how I was using it initially. I was creating reusable components for everything. I was using theme only a little bit, and everything, even if it was mostly styling, it was separate reusable component. That's not my recommendation. But in use cases where you actually want to add some additional prompts to the component, it is a very good solution. So you can enhance components however you like, and then just reuse it all over the place. Next thing, you can provide the CSS baseline, baseline, yeah, that's how it's called, for your application, and some global style overrides. I didn't see global styles Sote, but with the CSS baseline, which you can also address while creating your theme object, it is a very nice solution for everything that's general or global for your application. So that's it. And last but not least, actually the greatest one, is the theme object that you can create using the create theme function. As you can see here, you provide some initial data, and then the theme is generated specially for you. And it can be very minimal or a little bit more advanced. But what is very nice, you can relate to any component in the theme object and create your own theme for the specific component. So you don't have to create reusable components if you want to style everything. You can style it in the theme, and you can even set default props. I will show you this in practice just in a moment. Yeah, and to use it, you use theme provider infrastructure. You can find in the documentation easily. Okay, that's the part to love the most. Okay, so you did have some theory. Hopefully you liked it. And now I will show you some coding. So let's this should work. Right, now we're ready. Okay, that's the demo I have prepared for you. And actually, I want to start without a theme. So let's just comment this out. There's some other context I didn't remove. Okay, that's out-of-the-box material UI components with no modifications. It's not ugly, not beautiful. Usable, accessible, with all the area attributes set properly, with all the area roles set properly, with all the underneath components used properly. Very high standard, very nice. Not visual though. Okay, so let's apply the custom theme now, and then we will play a little bit with theming. This should, don't have to rebuild it. My computer doesn't really want to cooperate today. I'm sober and it's probably drunk instead of me. That's the only explanation I accept. Hey. It did render, I just didn't spot the difference and you didn't tell me. I'm not sure if I like it. Okay, so it's changed a little bit, the blue is a bit darker, the violet from here disappeared. Not sure if you spotted it, but previously all the components were a little bit elevated with some shadow. Now it's there's no shadow for this. But this is not the funniest thing. So one of the funniest things is with just one small modification here, we can make it all magenta. It took that long, and as you can see, the theme was regenerated with the magenta as main color, and all the variations of this is automatically generated based on this main color. You can do this the same for the secondary and for any other color. You can set the default backgrounds, anything really you want. Super easy. So we have. I want to show you default props also because it's nice. So here we have default props set for disabling elevation. But when we click the button, we have this very nice ripple effect. Can you see it? Yeah. And also we have default size of the buttons, which is, I think, medium. So let's change it and see what happens.